Hello, and welcome to my screencast presentation about and inspired by Salman Kahn, the creator of the free online learning interface called Khan Academy. I'm Jen Stainton, a student in curriculum leadership at the University of Vermont. The goal of this screencast is to share the work of a person I identified to be a modern key thinker in education, Salman Kahn. Sal Khan was born on October 11, 1976 in New Orleans. His mother was born in India, and his father was born in Bangladesh. Kahn attended public schools in New Orleans and then attended MIT and Harvard. He became a financial analyst after grad school. He later became a large influence on how education works in America. Why did I choose Mr. Kahn for this assignment? Well, it started with a conversation I had with a student of mine, whom I'll call John. John is a highly motivated student at my school, and he decided to take advantage of Vermont's dual enrollment program by taking a calculus class at a local Ivy League college. One day, Jack came to visit and expressed his frustration about the class. "You see, Mrs. Stainton," he said, "we learn on our own through Khan Academy. Our time at Dartmouth is simply tutoring by a grad student to help us understand the content of the videos. We're even assessed through Khan Academy." That was shocking to me. Dartmouth College was using Khan Academy videos to teach and assess their students, not assistant or tenured professors. It was at this moment that I realized just how much of a change Khan Academy was making to the world of education. I'm going to show you a video here about Khan Academy and who Sal Khan is. This is a 2011 TED Talk titled, "Let's Use Video to Reinvent Education," and it'll tell us more about the origins of Khan Academy.
Really just how I got started. And some of y'all might know, about 5 years ago, I was an analyst at a hedge fund, and I was in Boston, and I was tutoring my cousins in New Orleans remotely. And I started putting the first YouTube videos up really just as kind of a nice to have, just kind of a supplement for my cousins, something that might, give them a refresher or something. And as soon as I put those first YouTube videos up, something interesting happened. Actually, a bunch of interesting things happened. The first was the feedback from my cousins. They told me that they preferred me on YouTube than in person. And once you get over the backhanded nature of that, there was actually something very profound there. They were saying that they preferred the automated version of their cousin to their cousin. At first it's very unintuitive, but when you actually think about it from their point of view, it makes a ton of sense. You have this situation where now they can pause and repeat their cousin. Now they can, without feeling like they're wasting my time, they could, if they have to review something that they should have learned a couple of weeks ago or maybe a couple of years ago, they don't have to be embarrassed and ask their cousin. They can just watch those videos. If they're bored, they can go ahead. They can watch it at their own time, at their own pace. And probably the least appreciated, aspect of this is the notion that the very first time that you're trying to get your brain around a new concept, the very last thing you need is another human being saying, "Do you understand this?" And that's what was happening with the interaction with my cousins before, and now they could just do it kind of in the intimacy of their own room. The other thing that happened is, I put them on YouTube just for the, I saw no reason to make it private, so I let other people watch it, and then people started stumbling on it, and I started getting some comments and some letters and all sorts of kind of feedback from random people around the world, and these are just a few. This is actually from one of the original calculus videos, and someone wrote just on YouTube, it was a YouTube comment. "First time I smiled doing a derivative." And let's pause here. This person did a derivative, and then they smiled. And then in response to that same comment, this is on the thread, you could go on YouTube and look at these comments, someone else wrote, "Same thing here. I actually got a natural high and a good mood for the entire day. Since I remember seeing all of this matrix text in class, and here I'm all like, I know Kung Fu." And we got a lot of feedback along those lines. It's clearly it was helping people. But then as the viewership kept growing and kept growing, I started getting letters from from people, and it was starting to become clear that it was actually more than just a nice to have. This is just an excerpt from one of those letters. My 12-year-old son has autism and has had a terrible time with math. We have tried everything, viewed everything, bought everything. We stumbled on your video on decimals, and it got through. Then we went on to the dreaded fractions. Again, he got it. We could not believe it. He is so excited. And so you can imagine, here I was.
From Mr. Kahn's humble beginnings of creating videos for family, he grew a video tutorial empire. Today, Khan Academy has 80 employees and over 500 million videos and has infiltrated classrooms from the elementary through college level. One of the main ways I've seen Khan Academy used in schools is similar to the way it was used in the calculus class at Dartmouth, in something called the flipped classroom. So what's the flipped classroom? I'm going to show you a quick video.
The flipped class requires us to fundamentally rethink two important aspects of education: space and time.
So let's talk a little bit about space. If you think about the way classrooms have been set up traditionally, they had a chalkboard in the front of the classroom. Then those chalkboards became whiteboards, and then those whiteboards became overhead projectors, which then turned into LCD projectors that we hung on the ceiling. But really the classroom in all of those situations is a presentation station. It's not a center of learning. When we rethink the space of the classroom, we're reorienting how the classroom is used, where the front of the classroom is or where the front of the classroom isn't.
All you have to really do is rethink where you're going to put tables and chairs. But then that begs a very interesting question. Now, what do you do with the extra time you're going to have in a flipped classroom with the kids?
The short answer is we don't know what the best use of your face-to-face class time is, but what we want to encourage you to do is to think about ways you can get your students engaged in some of the higher order thinking, the higher tiers of Bloom's taxonomy, the analysis and application and evaluation and creation components, all within the context of the content that they've already learned before they come to class in better ways with an expert in the room, a content area expert and a learning expert, and that expert is you.
This probably sounds familiar. Project-based learning, PBL, universal design for learning, inquiry learning. These learning pedagogies fit greatly in a flipped learning environment.
In short, a flipped classroom is a way for teachers to transition into the role of facilitator, becoming that guide on the side. We really see the flipped classroom as a transitional tool for educators to move away from being the center of attention in the classroom and move that attention onto students and onto the learning that's happening in those classrooms.
I don't flip my classroom every day, but some of my lessons are best taught in a flipped model. For instance, in chemistry, there is some content that's easily taught via video. If I assign the video for homework, I can then use class time to assist my students with their understanding, have them work in small groups to deepen understanding, and focus on responding to and differentiating for my students, instead of simply delivering content to them all the time. It allows me to build a more constructive classroom. Let's hear more from Kahn to understand his philosophy.
The question is, how do we take this to the next level? How do we take what those teachers were doing to their natural conclusion? And so what I'm showing over here, these are actual exercises that I started writing for my cousins. The ones I started were much more primitive. This is a kind of a more competent version of it. But the paradigm here is we'll generate as many questions as you need until you get that concept, until you get 10 in a row. And the Khan Academy videos are there. You get hints, the actual steps for that problem if you don't know how to do it. But the paradigm here, it seems like a very simple thing, 10 in a row, you move on. But it's fundamentally different than what's happening in classrooms right now. In a traditional classroom, you have a couple of homework, lecture, and then you have a snapshot exam. And that exam, whether you get a 70%, an 80%, a 90%, or a 95%, the class moves on to the next topic. And even that 95% student, what was the 5% they didn't know? Maybe they didn't know what happens when you raise something to the 0th power. And then you go build on that in the next concept. That's analogous to, imagine learning to ride a bicycle. And I give you a bicycle, maybe I give you a lecture ahead of time, and I give you that bicycle for 2 weeks, and then I come back after 2 weeks, and I say, well, let's see, you're having trouble taking left turns, you can't quite stop. you're an 80% bicyclist. So I put a big C stamp on your forehead, and then I say, here's a unicycle. But as ridiculous as that sounds, that's exactly what's happening in our classrooms right now. And the idea is, you fast forward and good students start failing algebra all of a sudden and start failing calculus all of a sudden, despite it being smart, despite having good teachers, and it's usually because they had these Swiss cheese gaps that kept building throughout their foundation. So our model is learn math the way you would learn anything, like the way you would learn a bicycle. Stay on that bicycle. Fall off that bicycle. Do it as long as necessary until you have mastery. The traditional model, it penalizes you for experimentation and failure, but it does not expect mastery. We encourage you to experiment. We encourage you to failure, but we do expect mastery.
Kahn philosophically is a mix of essentialist and progressivist combined. He believes there are key topics and information students must know to the level of mastery, and he provides the essential content through all of his video lectures. How he hopes lectures are used, however, makes him a progressivist. He believes education should be differentiated and personalized for each student. He also believes education should be free and accessible to all. Kahn believes all students can learn, as seen on Twitter here under the hashtag #YouCanLearnAnything. He works to keep the videos on Khan Academy free to anyone and has elicited large amounts of funding from the likes of the Gates Foundation, Google, and Microsoft. He's also presently soliciting donations from Khan Academy users, as I recently found out through email. Here is how Khan Academy is being used in some school districts.
But what we want to do is use the natural conclusion of the flipping of the classroom that those early teachers had emailed me about. And so what I'm showing you here, this is actually data from a pilot in the Los Altos School District where they took 2 5th grade classes and 2 7th grade classes and completely gutted their old math curriculum. These kids aren't using textbooks, they're not getting one-size-fits-all lectures, they're doing Khan Academy, they're doing that software for roughly half of their math class. And I want to make it clear, we don't view this as the complete math education. What it does is, and this is what's happening in Los Altos, it frees up time. This is the blocking and tackling, making sure you know how to do the system of equations, and it frees up time for the simulations, for the games, for the mechanics, for the robot building, for the estimating how high that hill is based on its shadow. And so the paradigm is the teacher walks in every day, every kid works at their own pace, and a teacher this is actually a live dashboard from Los Altos School District, and they look at this dashboard. Every row is a student. Every column is one of those concepts. Green means the student's already proficient. Blue means that they're working on it, no need to worry. Red means they're stuck. And what the teacher does is literally just says, let me intervene on the red kids. Or even better, let me get one of the green kids who are already proficient in that concept to be the first line of attack and actually tutor their peer.
Here's how one teacher is using Khan Academy in schools.
Hi, my name is Julianne Russell, and I am making a video to talk to you about some of the ways that I try to encourage and motivate my students to work on Khan Academy, both in the classroom and outside of the classroom. So for starters, I'm going to take you out in the hall. Pardon the noise, it's kind of active school day, and I'm going to show you some of the posters that I've made to just generate enthusiasm. So last year I had some pretty homemade posters and they were great, but I did spend some time this summer getting a little fancier, and you can see that I teach multiple classes, and every one of those classes is involved in what we call a Kahn test every couple of weeks. And so I want to talk about some of the metrics that I believe are important. So first of all, about every 2 weeks I post the dates, and I recognize the student from each class that had the most number of mastered skills. I think mastered skills are important because it shows you that students are practicing mastery challenges and leveling up their skills, and the only way to level those skills up is to do mastery challenges. I also focus on the student that has the most badges earned, and the reason I do that is because the badges are important to these students. And Khan Academy put a lot of research into what kind of rewards are important to students. badges were important. Even though they're virtual, it matters to them, so I recognize them. I also talk about the time spent in each class. That's important.